All right, students, welcome. We're going to be talking about the unit circle, and particularly the coordinates, not just the radian angles, but the actual coordinates. Okay, so what that is any point on the unit circle has an x and y coordinate associated with it, because the unit circle is on top of the x, y axis. Okay, so what are these coordinates? Well, they vary, and it goes around a circle, so that's a little bit complicated. But it's not as bad as it might seem. Because someone figured out, said, hey, instead of remembering the x and y's, what if you just remember the angle that it's at? Okay? Because if I rotate, like say this is at 25 degrees, rotating 25 degrees will get me here, and all I have to remember is 25. Or I could remember two coordinates, x and y. Either way, they're both the same. It's just two different ways of measuring or recording your coordinates. So what someone said is, wait a minute. Well, if you draw this down, the x coordinate is just the side of this triangle. All right? And the height is just the y coordinate of this triangle. So the base and the height of the triangle just correspond with the x and y. This is a right triangle, so it has a hypotenuse, and the hypotenuse here is 1 because, as we said, it's a unit circle. It's a 1-unit circle. Okay, so how does that help us? Well, what it is, someone said, instead of remembering the x and y, let's think of everything in terms of theta. In fact, let's write an equation that represents theta and in terms of x and y. So they said, okay, well, if you want the cosine of theta, that would be the adjacent over hypotenuse, or x over 1. But x divided by 1 is just x, so then... Okay, so x over 1 is the same as just x. So in other words, the x coordinate is the same as the cosine of the angle. So if you know the angle, then you can find the x. Or if you know the x, you can work backwards. That's what we'll be able to do. It's basically another way to write the angle. Same thing. For the y, if we said sine of the angle, the sine is the opposite over hypotenuse. So y over 1. Or sine of theta equals just y. So what that is then is now, for every point, you could write it as x or y, or you could think of it as being the cosine and the sine. Then you just have to remember the angle and then use a calculator for cosine or sine. Okay? In fact, we won't even have to use the calculator. We're going to have a method for that I'm going to show you right now. So, this is important. Let's put a box around this. This is critical. Okay? So if this part doesn't make sense, watch it again or ask me questions in class to explain this, because this is critical. Okay, now let's go back to talking about coordinates. All right, here. So, let's see. We got part of a unit circle here. Let's draw top half, bottom half. Okay, and so here's what we got. You've got your unit circle, and let's start with our first angle, which is 30 degrees. How do you find the coordinates of that? Honestly, it's not easy, unless you know this trick. It's just the cosine and the sine of that angle. So if you're at 30, the x and y are just cosine of 30 and sine of 30. Well, how are you supposed to know that? Well, that comes back to those two special triangles from the other video. So hopefully you know these two triangles, because we're going to use them over and over. What this is, that's the 30, the 60, and you got the 90 degree. And this triangle, if you recall, the sides are 1, 2, and rad 3. So we need to know this triangle. It's very special, and it's easy to remember. The short side's 1, the long side's 2, so 1, 2, and it's a 1, 2, 3. But really, it's a 1, 2, rad 3. So back to this. What's cosine of 30? It's adjacent over hypotenuse, so rad 3 over 2. To find the y coordinates, that's the sine of 30, opposite over hypotenuse, so that's 1 over 2. Okay, and there's your first coordinates. And it's that easy. If you know the triangle, you should be able to find the coordinates real quickly. Moving up to 60, okay, same thing. The coordinates would be cosine of 60 and sine of 60. All right, so cosine of 60 and sine of 60. Now you're looking at from this angle. Cosine would be adjacent and the hypotenuse, 1/2. And the sine of 60 is opposite over hypotenuse, which is rad 3 over 2. And there you go. You got most of the first quadrant filled in. 45s, you'd need the other triangle, but it's exactly the same method. Sine of 45 and the cosine of 45. Okay, that'll give your y and your x. All right, so that's a big part of the unit circle. Now you don't have to memorize it. You can generate it all knowing this triangle. Okay, last bit here to fill in the rest of this unit circle. If you're over here at 150, what turns out is even though you rotated to 150, the triangle that's formed there has a 30-degree angle. So even though you're trying to find cosine and sine of 150, it's really the same triangle. So it's like if you had this triangle here, if you flipped it across the y-axis, if you reflected it, it'd be the same exact triangle. Okay, so 30-degree here and a 150 here, they're the same. The difference is with the rad 3 over 2 and the 1/2, the x-coordinate is negative. Because in this quadrant, it's a negative positive. Whereas this quadrant, everything's positive. So now you got your 150. It's the same as your 30. Same thing up here. 120 is a multiple of 60, so it's the same thing. It's the 1/2 and rad 3 over 2, but the x-coordinate's negative. Okay, because again, you're thinking about a triangle here. Same exact triangle over here, it's just on the negative side. Okay, and then finally, same thing can be done with the other two quadrants. Reflect it down here. This one down here will be the same as the 30. Same coordinates, positive and negative. Positive x and negative y. Because in this quadrant, it's positive, negative. And then the same thing over here, negative, negative. Okay, so the numbers are all the same for any quadrant. A 30 is the same here as it is here, as it is here, as it is there. Okay, what changes is the positive, negative, the sign of it. Okay, so with that, knowing that every coordinates x and y could be written as cosine and sine, and knowing the special triangles, there you go, you can generate the entire unit circle. You shouldn't have to memorize it. You should just know this triangle, and you should be able to get this fairly quickly without too much thinking or too much, stress. All right, I hope that makes sense. If it doesn't, please email me or bring questions to class, and have a great afternoon, you guys.